Today we're going to be talking about the indefinite integral. And technically we've already done this. We did this back in chapter 5 when we were finding the antiderivative. But I'm going to give you guys some rules that are going to make your life a little bit easier. So find out possible functions f with the given derivative. Remember, okay, so this is my derivative. I now need to come up with f of x. So when we're looking at this, what we're doing is we're like, okay, what do? I have to add 1 to the exponent, because remember, I'm reducing this exponent by 1 to get my derivative, and then I usually bring down that coefficient. Well, that coefficient now is 1, so you take 1 over the new exponent plus some constant of variation. So that's one possibility. Here's another possibility. Here's another possibility. Remember, we had a lot of possibilities way back when we were doing this in chapter 5. So what did we do? Okay, when you take the derivative of each one of these, you realize you do get this f prime of x. So what did we do? We added on a constant. So this should equal 1/3 x cubed plus c. So this is what our antiderivative, or all possible functions that have the derivative of x squared. Because if I now take the derivative of this, f prime of x, remember I bring down the exponent, 3 times 1/3 is 1, and I reduce my exponent by 1. The derivative of a constant would be 0. So I get what I was looking for. Okay, so a function f is called the antiderivative on an interval if when I take the derivative of my function, I get my derivative out. Or, now going backwards, this is where this integral, okay, we've been talking about this sum. We integrate the derivative to get out the antiderivative. Okay? And don't forget your plus c. That's important. So therefore, the integral of x squared dx, remember this is the derivative. What function's derivative is x squared? That's 1/3 x to the third plus c. So what's our rule? Our rule, and this is important, our book really doesn't talk about this. Okay, you add 1 to the exponent, and you take 1 over that exponent plus c. Okay, so that's the key here. This is super important. Okay, so evaluate each definite integral. What I like to do is I like to add 1 to my exponent, then take the reciprocal of that, throw that in front, and don't forget your plus c. For the next one, rewrite this. Remember, the dx is telling us what we're taking the integral with respect to. Everything else would be considered a constant. So I do see my variable x there. Add 1 to the exponent. -5 plus 1 is -4. And 1 over the reciprocal of that new exponent plus c. Remember, you could always take the derivative of each one of these to make sure that you're getting back the function that's inside here. And if I take the derivative of each one of those, I do get that. All right, the next one. I'm going to write that as x to the 4/3 dx. Don't forget your dx. Okay. I have to add 1 to this exponent. So that's going to be 7/3, and then take the reciprocal of that. And don't forget your plus c. Okay, some properties of integrals, and we've kind of already talked somewhat about these. A constant can come out in front. We talked about that in the previous video. I've already given you these rules. And then what you could do is you could break down each integral under addition or subtraction. So something like this can be broken down into the integral of x to the third dx minus 4 times the integral of x dx plus the integral of 2 dx. Okay, so now add 1 to your exponent, and you take the reciprocal of your new exponent. Add 1 to your exponent, so I have x squared. Your constant becomes 4 over 2, or 2. Add 1 to your exponent. Your exponent here is x to the 0 power, so that becomes 2x. Don't forget your plus c. Now take the derivative of this, just to make sure that you get your right answer. I bring down the 4. 4 times 1/4 is 1, so that becomes x to the third minus the derivative of negative 2x squared is 4x. Derivative of 2x is 2 plus 0, so the c goes away. So this is what I started with. Okay, trigonometric integrals. Remember, okay, keep in mind, this is the derivative. So what function's derivative is cosine? That's sine. What function's derivative is sine? That's the negative cosine. Because when I take the derivative of cosine, I get negative sine, so I have to add in a negative there. Okay, so please make sure you guys write these down, because these are going to be super important to us. Okay, trigonometric integrals. Notice how I've never talked about some sort of quotient or product rule. Okay, so I'm going to have to manipulate this in some way. I'm going to have to manipulate it into an integral that we're going to recognize. So I'm going to manipulate this into the cosine of x over the sine of x times by 1 over the sine of x dx. So cosine over sine is cotangent. 1 over sine is cosecant. Don't forget your dx. So now, what function's derivative is cotangent cosecant? That's the negative cosecant of x. And don't forget your plus c. Now manipulating this integral, okay, keeping in mind manipulating this integral. Again, we don't have a product rule, but we do have where I can manipulate this into t squared over t to the 4th minus 2 t to the 4th over t to the 4th dt. I just basically separated out my numerator under t to the 4th, which is our common denominator. Now I'm going to simplify that to t to the negative 2 minus 2 dt. Now I'm going to add 1 to this exponent. Adding 1 to that exponent gets me negative 1. 1 over negative 1 is negative 1 minus 2t plus c. Okay, exponential and logarithm integrals. Please make sure you write down these rules. Okay, the integral of e to the x. What function's derivative is e to the x? Well, that's e to the x. What function's derivative is b to the x? That's b to the x over ln of b. Okay, keep that in mind, because the derivative of b to the x, d dx of b to the x is equal to b to the x ln of b. So how do I get back when I'm taking the derivative of this, just regular old b to the x, well, I have to cancel out the ln of b's. And then what function's integral is 1 over x? Okay. What function has the derivative of 1 over x? Well, that's the ln of x. And make sure you add in those absolute values, because remember that x can only be positive. All right. And again, make sure you have these written down in your notes. These are key. Okay. The integral 3 to the x. Well, what function's derivative is 3 to the x? That's 3 to the x over the ln of 3 plus c. Okay, now I'm going to take the derivative of that just to show you guys that the ln of 3 cancels. So the derivative of 3 to the x is 3 to the x times by the ln of 3. Now keep in mind that we have this ln of 3 on the bottom. That's a coefficient. So I just tag that coefficient along with it. Those ln of 3's cancel. And I get what was inside my integral. All right, b. I could pull that 4 out in front. E to the x dx. Okay, the integral v to the x is just e to the x. And our last example, I can pull that negative 3 out in front. So I have the integral of 1 over x dx. What function's derivative is 1 over x? Well, that is, I was already thinking about my ln, the ln of x plus c. And again, remember, each one of these answers you can then take the derivative of, and hopefully you should get the inside piece. All right, that's it for today. Please make sure your lesson summary is submitted on time.